Today we are going to talk about solving proportions. Our goal is to solve proportions. Yesterday we stopped after the setup. Okay, so last class we learned how to set up and write proportions. Today we want to actually solve them. When we write proportions, remember that we always start with our word ratio. So you must have a word ratio for every single problem you complete, every single one of them. It doesn't matter which is in the numerator and the denominator like it did for unit rate, but whatever you do, it must be consistent throughout the entire problem. After you set up your word ratio, you will move to your skeleton proportion and you're set up ready to go. So every single proportion you set up should have your word ratio and skeleton proportion. Even as we solve today, every single one of them. Okay, so let's go down to our first example. It says that we are going to do this in two different ways, actually. So the first way, we are just using our mental math knowledge of multiplication and division. So it says you can buy 3 packs of Skittles for $5. Write and solve a proportion to determine how many packs I can buy for $20. So here I am comparing packs of Skittles and my money. I know how much money I spent, so I'm simply comparing my packs to my money. So I'm going to start by setting up that word ratio, packs. Again, remember, we don't care which is in the numerator and which is the denominator this time, as long as it stays consistent throughout the entire problem. I set up my word ratio, my skeleton proportion, and now I can begin filling in. Okay. So my first ratio is 3 to 5, 3 packs to $5. And then in my second ratio, I don't know the number of packs. That is my variable, but I know I have $20. Now, in this way, I am going to simply use my mental math capabilities and see how I get from one ratio to the next. So I look at my 5 and my 20 and I say, well, I know that I can get from 5 to 20 by multiplying by 4. Therefore, if I multiply 3 by 4, I can determine that x equals 12. Therefore, I can buy 12 packs of Skittles. And that is my answer. Okay, so we set up our word ratio and our skeleton proportion. We set up our first ratio, determined where our variable went. We used our mental math capabilities to see, okay, I know that 5 times 4 is 20. So if I multiply 3 by 4, these will remain proportional. 3 times 4 is 12. I have 12 packs of Skittles for $20. Let's do another example with our mental math. It says the distance traveled by Joe and Diane is in the ratio 3 to 5. The distance they traveled together was 24 miles. How many miles did Joe travel? So we are comparing Joe and Diane. That's who we're talking about. But what we know is the amount they traveled together. And specifically, I want to know about Joe. So Diane's information will help us, but I'm comparing Joe and the amount they traveled together. So this is a total problem. So we've got Joe and total in my word ratio. I set up my skeleton proportion. Now, my first ratio is going to be Joe. Joe is attached to the 3 because the Joe came first and the 3 comes first. Now, I'm not going to put 5 here because I'm looking for the total of these combined. 3 plus 5 is 8, so my first ratio is 3:8. My second ratio, I know that I have 24 miles together, so 24 is my total, and I'm looking for how many miles Joe specifically traveled. That's the unknown. That becomes my variable. Once again, I'm using mental math this time, so I say, okay, how do I get from 8 to 24? Well, I multiply by 3. Therefore, if I multiply my numerator by 3, my ratios will remain proportional. 3 times 3 means x equals 9. Therefore, Joe traveled 9 miles. One note here is that we don't want to put up here and say, put your x equals 9 right there. That's not correctly setting up your proportions. This is your problem. This is your equation. And then we have our solution off to the side. Putting the x equals 9 in your proportion is mathematically incorrect. So we do want to make sure we separate our proportion from our answer. So we do write x equals 9 in our sentence off to the side. All right, so this was using mental math. I knew my numbers. I know the multiplication and the division, so that was good to go. Now, let's try with the cross products property. We learned about the cross products property when we were practicing our proportions, determining if things ratios were proportional. So now let's put that to use with solving proportions. So our first example is you can buy 3 t-shirts for $34. Write and solve a proportion to determine the cost of 7 t-shirts. So I'm comparing here t-shirts and money. So I write my word ratio, t-shirts to money. Does it matter which one goes on the top or the bottom? Does it matter which one is in the numerator or the denominator? Nope, as long as it stays consistent throughout. Comes my skeleton, and now I set in my ratios. Okay, so t-shirts, my first ratio is 3 to 34. And then I want to know about 7 t-shirts. T-shirts are on top. So t-shirts go over here. My unknown is the money amount. So that becomes an X. All right, you ready? What we're going to do is the cross products property. We learned already that if I multiply across whatever I get as my product, so 34 times 7 and 3 times whatever X is, if those are the same products, then they will be proportional. So how do I do that when I'm missing a value? Well, I start by multiplying across what I do have. Okay. To show my work for this, I circle that I am multiplying this. This right here is showing me that I'm multiplying. 7 times 34. Over here, I'm going to write the product. That's 238. So then when I multiply 3 times X, I want my product, to be 238 as well. How do I make sure that happens? Well, I take my 238 and I divide it by 3. To show my division that I'm dividing, I put a box around it. Now, 238 divided by 3, you are welcome to use a calculator for this, is 79.33. Therefore, if I were to substitute in for X, 79.33, put that right there, 79.33 times 3 would get me the match of 238. Therefore, my X equals $79.33 for 7 t-shirts. And that's my answer. Oops. All right, let's do one more together. But before we do that, this is how you're going to show your work. I do need to see that you are multiplying and dividing. Like I said, you are welcome to use a calculator, but this is kind of a way for me to see what you're multiplying, what you're dividing. So I circle, take that oval across what I multiply, box what I'm dividing. I put my product here, box what I'm dividing, show my division problem, and then write my answer. If you have questions about that, let me know. All right, we're going to do one more together. I will help you get set up, and then I want you to try it on your own. It says the distance biked by Mary and Sean is in the ratio 3:4. The distance they traveled together was 30 miles. How many miles did Mary bike? So is this a part to part, or are we using part to whole? Good, because we're talking about the miles they traveled together, we are comparing a part, Mary, to the total. So what should my word ratio be? Well, I'm comparing Mary to total. I set up my skeleton proportion, and then I go ahead and plug it in. What will my first ratio be? I take Mary, which is 3, and then their combined total, which is 7. Where will my variable go in my second proportion? We are missing Mary, but we know our total, so Mary gets the variable. All right, what will I circle to multiply here? I circle diagonally my cross products, so I multiply 3 times 30. This gets me 90. What do I do with the 7? I box it to show division. 90 divided by 7, again, calculators are allowed, and I get 12 miles, 12 and 86/100 miles. So my answer is Mary biked 12 and 86/100 miles.